Okay, we're going to look at an example that's very similar to the problem that's on your assignment. So we have p of x equals 4 plus x when x is smaller than 0, and x cubed when x is greater than or equal to 0. So really these points over here, these bounds, really separate where the graph is going to appear. So 4 plus x is just a line. So if my x is smaller than 0, which is going to be on the left side, so over here, I would expect to see some kind of line. And on the right, I'm going to have x cubed. So x cubed is a cubic, kind of an S curve. So I would expect to see a cubic on this side. So the easiest way is to kind of make two tables. So I'm going to make a table for the line, an x and a y table for the line. And my line part, remember, is 4 plus x. And then I'm going to make a separate table for the cubic, which is x and y, and this is just x cubed. So whatever your functions are, and you could have many, many more tables. Now the trick is, for 4 plus x, I only want to pick x's that are less than or equal to 0. So some numbers less than 0 are -1, -2, -3. So those are all smaller than 0. I'm also going to pick 0, even though 0 is not really less than 0. But since it is kind of the breaking point, I'm going to include it, but I'm going to make sure I know that this is going to be an open circle. So it's going to get really, really close to 0, but not touch it. So if I plug all of these x's in for 4 plus x, so I'm going to do 4 plus all those numbers. So for example, I'll do 4 plus 0, which is 4. 4 plus -1, which is 3. 4 plus -2, which is 2. 4 plus -3, which is 1. So those are going to give me some points. So if I plot those, that's going to give me my line part. So I have 0, 4, 1, 2, 3, 4, which is going to be open. -1, 3, which is going to be there. -2, 2, which is going to be here, and then -3, 1, which is there. So this part of my graph is my line. So all the x's left of 0 are going to make that line. And the trickiest part definitely is making sure you do take 0, but it's an open circle because it strictly has to be less than 0. Now for the right part, I'm going to pick x's that are greater than or equal to 0. So I want to pick my x's greater than or equal to 0. So I'll certainly pick 0 and 1 and 2 and 3, whatever I want. And then I will plug all those x's into my x cubed. So I'll put all those into there to get my y's. Because for both of these, this is essentially y equals this and y equals that with these restricted bounds. So 0 to the third, 0 times 0 times 0 is 0. 1 to the third is 1. 2 to the third, 2 times 2 times 2 is 8. And 3 to the third is 27. So if I plot those points on my graph, so I get 0, 0, and this will be closed in this case because it is equal, so you count it. 1, 1, 2, 8, and it's going to kind of just take off like that, so it's going to look something like this. Because if you remember what a cubic looks like, it would continue to go like this, but we don't have that part because we're only looking at points that are greater than or equal to 0. So, best way to do these, make these little tables, pick the special x's, and then you can get a pretty good picture of what your graph looks like.